Hi, I'm Lily Shan. What I'm going to present today is about stereolithography printing. In the field of additive manufacturing, stereolithography, sometimes known as SLA 3D printing, is widely recognized as one of the most well-liked and widely used printing processes. A low-power laser is used in the process, which results in the solidification of a liquid resin that is held inside a reservoir, also known as a vat, in order to form the required 3D shape. In its most basic form, this process is known as photopolymerization, and it involves the transformation of photosensitive liquid plastic into photopolymerized solid plastic in a layer-by-layer method. In general, each and every conventional SLA 3D printer is made up of the following four basic sections, where this serves as the reservoir for the liquid polymer, which is usually a clear and liquid plastic called resin. Build platform. The platform is lowered into the vat and can move up and down according to the printing process. Ultraviolet laser. The laser clears the layer. Last, computer interface. An interface accessible on the printer itself manages both the platform and the laser movement. Now I'm going to present about the SLA 3D printing process. In the first stage of many additive manufacturing procedures, a 3D model is created using CAD or modeling software. The CAD files that are generated are digital representations of the desired object. The CAD file must subsequently be converted to STL format, Standard Tessellation Language (STL), also known as Standard Triangle Language, is a file format designed for stereolithographic printing. STL file only defines the surface geometry of a 3D object, ignoring common CAD model attributes like color and texture. Loading an STL file into 3D Slicer software, which is typically provided by the manufacturer, is the pre-printed step. This software then generates a set of motion commands that the 3D printer can understand. Second stage, printing. The laser is aimed into a pattern inside the vat termed a layer. As the process begins, the liquid freezes wherever the laser strikes. The photopolymerization process requires two components, a laser and liquid plastic, with the laser supplying the photo aspect. A computer-controlled mirror system known as a galvanometer or galvo for short directs the laser to the proper location. Following the first layer, the platform is elevated to the layer thickness, and new resin is allowed to flow underneath the already printed section. In actuality, the bed is frequently shifted considerably more to enable the viscous resin to flow more easily. The net cross-section is then solidified by the laser, and the process is repeated until the whole component is complete. The resin that does not come into contact with the laser stays in the vat and may be reused. The last stage is post-processing. The platform emerges from the time when the full 3D print is completed. At the completion of the procedure, the model is taken off the platform, rinsed with alcohol to remove excess resin, and put in a UV curing chamber. Post-print curing allows items to attain their maximum strength and stability. This post-curing enables the actual layer curing to take place with less electricity, which speed up the total process. That's all for the stereolithography 3D printing. Thank you.